All right, Camiah, this is for you. We don't know if it's going to work or not, but I'm trying to record this. Okay, we hope you're doing great. All right. So here we go. I want you to draw a point A on your paper, and then I want you to draw all points that are 2 inches from A. So how would we do that? Well, what I would do, the measurements are kind of weird on the compass, so what I would do is take your compass beside a ruler and just move it until they're 2 inches apart. Right? Okay. Now the easy way to lock this, it's not that easy to lock. What I would do is, instead of holding it on the handle, hold it down here where you're holding both sides of it. And the way you do it is you move the paper instead of the compass.
You don't lock it? You said don't lock it?
Well, there is no lock. But just hold your point still and move the paper, not the compass. And it's much easier to keep it at 2 inches. It's hard for me to do because the camera gets in the way, but you got it. Okay? So what did everybody draw? So you drew a circle with radius, what? 2 inches. Okay? So that was the second conic section we learned. I think we did parabolas first. Okay? But that's one of them. And the way it comes is from this. You're drawing all points that are a given distance from a given point. Okay? When you do that, you get a circle. All right. What is standard form for a circle?
X minus h squared plus y minus k squared equals radius squared.
Right. Where the center is at HK and the radius is R.
Do you have a
No. Okay. So that's that. All right. So now let's look at the next one. I want everybody to draw a straight line on your paper about one, if you cut your paper into thirds, and we're looking at it this way, about 1/3 of the way. Another sheet of paper. We're going to take notes like Angelo today.
You said 1/3.
So about 1/3 of the way across, draw a straight line.
Yeah, you're going to make funny at the moment.
Okay? Mm-hmm. Then I want you to put another sheet of paper so that it's a 90-degree angle. And draw a dotted line at a 90-degree angle. Okay? So draw a line and then draw a dotted line at a 90-degree angle. And you can use another sheet of paper to make sure it's 90 degrees if you don't have a protractor. Then, on that dotted line, I want you to measure and make a dot that is 2 inches from the first line you drew. So we're going to make a dot so that that dot is 2 inches from that line. Now, why was it important that this be a 90-degree angle? Anybody?
So you can measure the distance between the points.
Right. If I just said draw a dot that was 2 inches away, what you would have done is like gone 2 inches, right, and drawn a dot. But if you had moved your ruler, like that 2-inch dot could have been almost anywhere, right?
Yeah.
And you measure distance from a point to a line perpendicular, okay? So if I want to know the distance from this point to this line, it has to be perpendicular distance. I can't just draw any line and measure that line, okay? So since it's perpendicular, that's the only way to make sure that this is 2 inches, okay? So here, now I want you to draw, let's call this line D and point F. Now, I didn't choose those randomly, okay? I want all points that are the same distance from line D and point F. Okay. There's one that's really easy to draw. What's one point that we know that is the exact same distance from that line and that point? One like right here that is an inch from each, right? Since we know this is 2 inches, we could find the midpoint of that little segment. Right here, so that that's 1 inch and that's 1 inch, right? Okay. So that point is 1 inch from both line D and point F. Okay. Let's see if there are any points that are 2 inches away from both.
Eclipse?
Okay. Not yet. Okay, so
ellipse. I'm sorry.
how do we, where are all the points that are 2 inches from line D?
Like on the line.
So we need all the points that are 2 inches from line D. Where would that be? Okay, right. If there was a parallel line through F, and you can just kind of eyeball it. So let's draw that kind of dotted. Now there is another line that is 2 inches from D, right? But it would be on the other side, and all of those would be at least 4 inches from F. So we know it's not anything over there, because we want something that's both 2 inches from D and 2 inches from F, right? So these are all the ones that are 2 inches from line D. Okay, there's also some over here, but we know those aren't what we're concerned about because we're wanting things that are the same distance from both. Well, how could we draw all the points that are 2 inches from F? Or you could draw a circle with radius 2 around F. All right, so move the camera a little bit to see if I can make this work. Okay, I'm having to move the camera a good bit, so y'all keep an eye for me going out of bounds, okay? So on our, let's get our compasses and measure 2 inches. And let's draw a circle with radius 2 inches around F.
do that on my own.
And if y'all want to, I mean, you can go along, or you can just watch me and I can give you these too. Okay? I'd like for you to do it yourself, but if you get behind, we need to do them all. Okay? So, were there any points that are both 2 inches from D? So these are all the lines that are 2 inches, all the points that are 2 inches from point F. Right? So are there any points that are both 2 inches from D, so they'd be on this line, and 2 inches from F, so they'd be on this circle?
Is the two
Right here and right here. So we could see this point, it's 2 inches from D, but it's also 2 inches from F. So it's equal distance from line D and point F. Here's another one. 2 inches from D, 2 inches from F. Okay? Now let's do 3 inches.
So before you change, like, when you got the point where it got 1 inch from F and 1 inch from F. How did you mark it off? Because
I just knew that this was 2 inches, so I measured it and took the midpoint because I knew that it would be 1 inch from D and 1 inch from F.
Okay. So is there a possible way I could do like
With the circle?
I'm saying with the ruler. Like,
yes. You could have measured 1 inch and drew a line and then done a circle with radius 1 inch, and they would have only crossed at that one point. Okay, the only thing that would have been on that circle and this line would have been that 1 point. Okay, so now let's do 3 inches. Where are all the points that are 3 inches from line D? Well, if we measure 3 inches away, it would be right here. It's 1 more inch, right? So it'd just be a parallel line, 1 more inch. Okay, so these are all the lines that are 3 inches. I need to go further. Both directions, probably. Those are 3 inches from line D. Okay? What are all the points that are 3 inches from point F? Well, we could make a circle with what radius? 3 inches. With the center at F. Oh, shoot. All right, circle with 3 inch radius at F. Okay? So that circle is all the points that are 3 inches from F. So here, this line is all the points that are 3 inches from D. This circle is all the points that are 3 inches from F. Are there any points that are on both? Yes, right here and right here. Okay? If we were to do 4 inches, we would have a line here, right? And a bigger circle. They would cross like here and here.
Can you draw it if you want to?
If you want to, yes. Right? If we were to do 5 inches, we would have a line here and an even bigger circle. They would cross here and here. We would have a line here that's 5 inches from F. We would have a circle with radius 5 inches from D. We'd have a circle radius 5 inches from F, and those two would cross here and here. If we connect all the points that cross, look at what we have. So every point on this parabola, every point here, if you picked a random point, so let's say right here. Okay, here's our random point. If you measured its distance to D, which has to be perpendicular, and you measured its distance to F, those would be congruent. And they are. Okay, pick another point here. You measure its distance from D perpendicular and its distance from F, those would be congruent. And they are. Okay? So that's where a parabola came from. A parabola is all the points that are the same distance from a line and a point. That line is the directrix, which is why I called it line D. That point is the focus, which is why I called it point F. Okay? Standard form, there's 2 forms of it. There's a y equals and there's an x equals. Okay? The y equals is y equals a x minus h squared plus k. The x equals is x equals a y minus k squared plus h. And in each one of them, the vertex is what? HK. Here, if A is positive, it opens up. If A is negative, it opens down. Here, if A is positive, it opens right. If A is negative, it opens left. In both cases, the length from the focus to the vertex or from the directrix to the vertex is what?
1/4a.
The absolute value of 1/4a. And what is the length of the lattice rectum?
Absolute value.
Absolute value of 1/a. You got it. Okay? All right. So then, now, I want you to draw 2 points that are 3 inches apart. So any 2 points that are 3 inches apart.
How many?
3. So let that be 3 inches.
2 point. Yeah, that's one.
2 points that are 3 inches apart. And you call one A and one B. Okay? Once you do that, okay, I'm wanting to, sorry, I'm replying to an email really quickly. Yeah, Camiah was like, what? All right. I want all points all points that when you add the distance to A and the distance to B, you get 5. Okay, so how is that possible? Well, you could be 1 inch from A and 3 inches from B. I'm sorry, 4 inches from B. Yeah, sorry. So you could be 1 inch from A and 4 inches from B. Okay? So let's see if there are any points that that's true. Okay? If there are any points that are 1 inch from A but 4 inches from B. So how do we get all the points that are 1 inch from A? Circle with radius 1. So make your circle have radius 1 and draw all the points that are 1 inch from A. Okay, so these are 1 inch from A. Okay. So then 4 inches from B. How could we get all the points that are 4 inches from B? We need to draw a circle of radius 4 from B, right? Circle with radius 4 from B. It is a wide circle. So there are all the points that are 4 inches from B. So were there any points that are on both circles? There's one right there. So that point is 1 inch, and that makes sense because look, if it's on a straight line, we knew A and B were 3 inches apart, right?
You said how many inches apart?
A and B were 3. So if that's 1, then that's 4.
I don't know.
I thought they were supposed to be 10.
How did I get that?
Make sense? Yeah.
They don't touch.
Well, there's barely don't touch. They
Wait,
should.
I got a question. On the original, the points were supposed to be 2 inches apart.
3 inches apart. Yeah, just follow along because you're going to be lost now. Okay, so there was 1 point that was 1 inch from A and 4 inches from B. Okay, what's another way that the sum of them could be 5? You could be 2 inches from A and 3 inches from B. Right? Okay, let's do that. So let's do a circle with radius 2. Circle with radius 2 from A. And again, it's easier if you move your paper instead of moving the compass. Okay, there are all the points that are 2 inches from A. And then let's do 3 inches from B. Well, we know that A is 3 inches from B, so you could actually just do the circle through A. Right? Because if A is already 3 inches, then A would be on that circle. Okay, so these are all 3 inches from B. So were there any points that are on both the circle that is 2 inches from A and the circle that was 3 inches from B?
Those two.
Right here and right here. Right? That point, distance from A is 2, distance from B is 3, so if you added those together, you get 5. This point, distance from A is 2, the distance from B is 3, you add that together, you get 5. Okay, what's another one? 3 inches from A, 2 inches from B, but there's a one I want to do too. You could be 2.5 from both. 2.5 from A, 2.5 from B. Okay, which would be a point that is the same distance from A and B. Okay, so let's do 2.5 from A. So we're doing a circle that is 2.5 inches from A. Okay, there's all the points that are 2.5 inches from A. Same circle from B. Okay, there are all the points that are 2.5 from B. Are there any points that are on both of those circles? There's this one and this one. Right? Okay, now we can do the other one you said. We could be 3 inches from A and 2 inches from B. Right? Well, 3 inches from A, we know that B is 3 inches from A, so we could just draw the circle that goes through with center A that goes through B. Because we know that B is 3 inches from A. Okay. Oh. There are all the points that are 3 inches from A. So 3 inches from A. Okay. Then we need 2 inches from B. What I'll do is measure off the 2 from here and use that one. So that was our 2-inch circle. So let's do it from B. Okay, there are all the points that are 2 inches from B. Bless you. So were there any points that were on the 2 inches from B circle and the 3 inches from A circle? Yes. Right here and right here. Right? Okay. Lastly, we have, you could be 4 inches from A and 1 inch from B. Okay, so 4 inches from A. We've already got one 4-inch circle here, so let's measure that. And we'll just do that from A. Now,
You said 1 from B?
4 inches from A and 1 inch from B. So there's all the points that are 4 inches from A. Mine went off the page, but that's okay. 4 inches from A is this big circle. So that's 4 inches from A. And then 1 inch from B. We've got a 1 inch circle here. So copy that over here at B. Here are all the ones 1 inch from B. So was there any points that was on the 4 inches from A, the big circle, and the 1 inch from B? It was just this one point right there. Right? So every point I've drawn, if you take the distance from A and the distance from B and add them together, you get 5. We've drawn 1, 2, 3, 4, 5, 6, 7, 8 points. If you connect them all, you have a nice ellipse. Okay? These 2 points are the foci. Okay, so you get an ellipse with foci A and B. All right? What is standard form of an ellipse? In my definition, it's x minus h squared over the x radius squared plus y minus k squared over the y radius squared equals 1. The only other formula you have is if C is the, what is C? It's the distance
From the foci to the center, or the vertex.
or center, from a focus to the center, and you have C squared equals A squared minus B squared. What is A squared?
The major.
The major radius, whichever one of these is bigger, squared, and B squared is the minor radius, whichever one of these is smaller, squared. And the focus is always on the major axis. Okay, not on the minor. Focus is always on the major axis. So those are the ones we've done so far. Okay? Now, let's do one more, the last one. Okay? And to save time, I'm not going to do the geometric way because I want to get to solving some problems with it, okay? But you'll just have to trust me that if you were to say you have a point A here and a point B here,
Yes.
okay? So if you just had an A and a B, and I want all points that
You want us to do letters?
no. All points that the difference in the distance to A and to B is 1. Okay? Well, here would be a point because that's 2 and that's 1, right? And 2 minus 1 is 1, right? Here would also be a point because that's 1 and that's 2. And the difference in those is 1, right? Okay. Here would be a point because that's 2 and that's 3. If that were 2 and 3. Okay. Here would also be a point because that's 2 and that's 3. Their difference is 1. Here would be a point because that's 2 and that's 3. And here would be a point, 2 and 3, right? Then you'd have another one like here. If this were 3 and that were 4. You'd have another one like here if this were 3 and that were 4. You'd have one here if this were 3 and that were 4. And you'd have one here if this were 3 and that were 4. Okay? When you connect them, it looks like 2 parabolas away from each other. Okay? And it's called a hyperbola.
Hyperbole.
Hyperbola.
I was thinking, I thought that was. I just might say something.
All right? I have a really country uncle who was taking college algebra one time, and he was like, Tori, I need to know about these hyperbolas. And I was like, oh my gosh. So it's not a hyperbola. It's a hyperbola. Okay.
Parabolas.
Okay, it looks just like the standard form looks just like a like an ellipse. You got me saying eclipse. Like an ellipse, except there are 2 ways it can happen. Okay, Okay, so far, everything I've written is the same as an ellipse, right?
Yeah.
Because it's the difference in the distances. An ellipse was the sum of the distances. Needed to be a constant. A hyperbola needs to be the difference of the distances to be a constant, so there's a minus.
So this is the opposite of a parabola?
No, of an ellipse. Okay? Yeah, you can write anything down. Okay, but it could be x minus y. It could also be y minus x. So you could have this. Okay, that's why there's kind of 2 forms. One is if the x is positive, one if the y is positive. Okay? So let me show you how to graph them. You start out graphing them just like an ellipse. Okay? So let me give you one. So let's say you had this. Okay, so if this were an ellipse, what would you do? If this were an ellipse, what would you do?
You would graph the vertex.
So the versus
Nope.
means the center.
The center would be where?
Who would be 3 negative 1.
3, negative 1. So 3, negative 1. Okay? Then what would you do?
Then you would graph the what is called?
The x radius, which is 4, right? So from here on the x, you'd go 1, 2, 3, 4 to the right. You would go 1, 2, 3, 4 to the left. Then what would you do on the y?
Got 3.
Go up 3, 1, 2, 3 up, 1, 2, 3 down. And then you would just connect those 4 points, right? That's what you do for an ellipse. You do everything the same for hyperbola, except when you get to where you would draw the ellipse, you draw a box, a dotted box. Okay? So this point is 3, negative 1. What is this point here? 7, negative 1. What's this point? Negative 1, negative 1. What's this point? 3, 2. What about this one?
-3.
No.
3, negative 4.
3, negative 4. Okay, now here's where it gets tricky. What about this one?
That is 7.
That's 7 positive 2.
7, 2. What about this one?
That's 1, 2.
Negative 1, 2. Okay. All right. So once you draw the rectangle, you then draw dotted lines through the corners. So dotted lines through the diagonals.
What's the difference between the vertex and the center?
Vertex is on, like a vertex is on a parabola. The center is not on an ellipse, a circle, or anything.
I meant the center.
Okay? So you draw the 2 diagonals, right? Now at this point, the hyperbola is either going to be here and here. These are your asymptotes. It's going to either be here and here, or it's going to be here and here, right? Well, the way you decide is whichever is positive, it opens in that direction. So x is positive, so you go to your x points. That's a vertex, that's a vertex. There's your parabola. Hyperbola. Okay? The only thing left that we didn't talk about is they will ask you for the foci and for the equations of these asymptotes. And we'll just get to that after the break.
Can you give me a copy of that?
Yes. I'll give everybody a copy of it if you'll come back later.
Hey, how did you figure out that those are hyperbola?
He said, but if the x was positive, you know how he said if you can rewrite it with the y first? If it was y first, then it would be on the y first.
Hey, I don't know how to stop this recording.
I'm sorry. Camiah, we're changing classes now.
Where were the rules?
I got their rules.
They were right here. Yeah. All right, here we go.
Definitely give you $1 or
Oh yeah, y'all are supposed to give me the $1 or canned goods. If you put it in the box, that's fine. Thank you, sir.
quarters.
You're good.
That's right.
Yes.
Lord, I hope my mom keeps remembering.
Hey, do you mind giving that packet to my dad?
Not at all. I'll do it.
I'll have a good
And
Thanksgiving.
I'll post this video if anybody wants it, because it's for Camiah. So, but yes, have a good Thanksgiving yourself. See you later.